With this video, we're going to be working on solving integer equations. First, a little vocabulary. We're going to be talking about inverse operations. Those are operations that undo each other when solving equations. The key word there is opposite. The opposite of addition is subtraction. Likewise, the opposite of subtraction is addition. They undo each other. The opposite of multiplication is division, and the opposite of division is multiplication. And since we said we're going to be solving equations with integers, let's just review the definition of an integer. Those are whole numbers and their opposites. Positive 3, negative 3, positive 5 and negative 5. Those are examples of integers. So let's get started. We're going to solve the equation x plus 13 equals negative 9. Now, one of the main rules when solving equations is anything that you do on the left side of the equal sign, you have to do the exact same thing on the right side of the equal sign. It's all about balance. If you have a scale, an old style pen scale, you're going to want to, if you pull something off of this side, you need to pull the same amount off of the other side in order to keep it even. Now, as a visual clue for you and for me, I like to draw what I call a balance line. It's a nice visual aid to help me remember that anything I do on the left side of that line, I have to do the exact same thing on the right side. So let's get started. X plus 13 equals negative 9. The operation that's happening here is plus 13. What's the opposite of plus or addition? Well, it's subtraction. So to get rid of a plus 13, we're going to apply the opposite of that, which is to subtract or minus 13. And since we're doing that on the left side of my balance line, we have to do the exact same thing on the right side of my balance line. On the left side, positive 13 minus 13. The 13s cancel and you're left solely with x. Bring down that equal sign. Negative 9 minus 13 is negative 22. I believe that that's the answer. But of course, since we're dealing with equations here, best thing we can do is to go ahead and check our answer. And you can check that answer by substituting or plugging in the number that we got to see if it works. We are saying that negative 22 plus 13 equals negative 9. Well, let's review our rules of adding and subtracting integers. The signs are different, so we're actually going to subtract them. The 22 has a larger magnitude than the 13, so we know that the final answer is going to be negative. And if I do it vertically, 22 minus 13, remember the rules of subtraction. 2 is smaller than 3, so we'll bring a 1 over, make it 12. Minus 3 is 9. This became a 1. Well, the answer is negative 9. That checks out, so we know we got the answer right. Now, what I like to do, and this is helpful with your instructor, this is helpful for yourself as you're checking your work, is to go ahead and put a nice little box around your answer to help you visually track your final end of the problem. Because while these are one-step equations we're doing right now, equations can really get up to just about any number of steps and can take off an awful lot of space on your paper eventually. So you want to get in the habit of doing something that identifies where your final answer is, whether that be boxing it, highlighting it, circling it, whatever works best for you. My favorite is boxing. So let's do another problem. Negative 8 plus y equals 12. Again, I'm going to start by introducing my balance line. It's my visual clue that helps me remember that if I do it on the left side, I have to do the same thing on the right side. Negative 8 plus y. We need to get rid of the negative 8. And we're adding. But it's a negative number. Well, that's where it gets a little bit weird. If you remember all the rules about adding and subtracting integers, subtraction and negative are two words that can almost be used interchangeably. The point is we have a negative 8 here, and the operation is addition. So to get rid of a negative 8, we're going to use the opposite. And the opposite of a negative 8 is a positive 8. We're going to add 8, or introduce a positive 8. And we have to do it on both sides of the equation. If we add positive 8 and negative 8, you get 0. So the only thing left there is y. And y equals 12 plus 8, which is 20. Again, the best thing to do is to make sure that we got that answer right. We're saying that negative 8 plus 20 equals 12. Well, negative 8 plus 20 is 12. That checks out. Let's go ahead and box that answer. Let's do another one, this time with some subtraction. We have x minus 32 equals negative 5. We'll start with my balance line. And we're subtracting 32. We need to do the opposite, which would be to add 32. And anything I do on the left side, I have to do the exact same thing on the right side. These two eliminate each other, giving you x equals, and negative 5 plus 32 is 27. I think that's the right answer, but it's always a good idea to check. I'm saying that 27 minus 32 is negative 5. And you know what? It is. So again, as a nice visual clue, I'm going to box up my final answer. So let's step away from addition and subtraction a little bit and take a look at some other operations like multiplication. When you see 12 or negative 12y, what we really have here is negative 12 times y. It's multiplication. So that's what we're going to be getting rid of. To begin, we'll put our balance line in. That is a step, by the way, that you do not have to do each time. It's a nice visual aid to use for a time. But if you find that you don't need to do it anymore, there's nothing wrong with stopping. But if you find as the problems get more complex, that maybe you start making some errors, having some mistakes, maybe it's a good time to introduce that back in as an aid to help you see what it is you need to be doing. So we have negative 12 times y, and to do, well, what's the opposite of multiplication? Division. All right, we're going to divide. Now here's a little hint or little trick. I can use that division symbol, the one that looks like this, but I'm going to let you in on a little secret. Fractions are division problems. If you see the number 2/3, yes, that is 2 things out of 3 pieces. But another way you can treat it is though we're saying 2 divided by 3. And the reason I'm bringing that up to you right now is visually, and it just stacks vertically better, if we just go ahead and say we're dividing both sides by negative 12. looks a lot like a fraction, but we are dividing by negative 12. Notice that I didn't change the sign of the 12. It's still negative, because the opposite of multiplying by a negative 12 is to divide by that same negative 12, unlike addition and subtraction where we change the sign. So the negative 12s are going to eliminate each other, and we have y equals, and 36 divided by negative 12 is negative 3. Of course, the only way to be certain is to check our answer. I am pretty confident we got it right, but let's do this anyway. We're saying that negative 12 times negative 3 equals 36. Now I'm going to pause here really quick because I just used a way of writing that you may not have seen a whole lot yet. I went ahead and put the negative 3 inside parentheses. And if you don't see an operator of any kind right here, well, the assumed operation is multiplication. So what this really is negative 12 times negative 3. It's a shorthand rather than always having to put those dots everywhere, especially since the dots can eventually start looking like decimal points. And, well, that's not something we want to deal with. And, of course, that X that we used to use to indicate multiplication, well, that looks a lot like the letter X, which is now a variable that we use. So we can't have that happen. But negative 12 times negative 3 is a positive 36. This does check out. So the answer is, in fact, y equals negative 3. Well, we did one with multiplication and using division to get rid of it. So let's finish up with a division that we have to use multiplication to get rid of. X divided by negative 9 equals 12. I'm going to still begin with my balanced line. And we're dividing both sides by negative 9. So what we're going to need to do is multiply both sides by negative 9. You can write it this way. You can write it using the parentheses I just showed you about and write it this way. It's totally up to you, whatever is most comfortable in your mind, whatever you like to see on your paper. The real point here is that we're multiplying both sides by negative 9. The 9's eliminate each other, giving us x equals, and negative 9 times 12, well, let's see, 9 times 2 is 18. Carry that 1. 9 times 1 is 9, plus 1 is 10. 108. That's the answer, isn't it? No. Remember the rule. Negative times positive. Negative 108. I believe that's the answer. Only way to be certain is to check it. We're saying that negative 108 divided by negative 9 equals a positive 12. Well, negative divided by negative is positive, so that part works out. And 9 does go into 108 12 times. It does check out. To finish this up, I'm going to go ahead and box up that answer. And that's how you solve algebraic equations with integers.